Hey, what's going on, guys? In this video we are going to see how to solve this first order linear differential equation with initial conditions. Okay, here the question is asking if a battery supplies constant voltage of 40 voltage and if inductance is 2 henries and the resistance is 10 ohm, given that I of 0 is equal to 0, find I of t and current after 0.1 second. Okay, so first we have this linear differential equation. Whenever we deal with a circuit, we always use this equation: L di by dt plus Ri is equal to E of t. So if it's inductance or capacitance, it can be inductance or capacitance. If it's inductance, this is the equation. If it's capacitance, there's another equation for that. Since we are dealing with inductance, this is the one we are going to use right now. L is given. L is the inductance, that is 2 henries right here. And also resistance, we have the resistance that's given right here, 10 ohm. We have the resistance. And also E of t is the voltage. Okay, that's given. So we have all these informations. We have to just solve this first order linear differential equation. Now let's go ahead and plug the values. L is 2 henries, so this is going to be 2 di by dt, and then plus Ri. R is 10, so 10 I, and then E of t is going to be 40 voltage. Okay, now this is not in standard form, because in the standard form of the linear differential equation you may have seen dy by dx. Here it's di by dt. Okay, it can be anything. It can be di by dt. It depends on the situation. Since we are dealing with time, it's di by dt. But usually the general pattern we write like this: dy by dx plus the function of x multiplied by y, that's equal to another function of x. That's the general formula of a first order linear differential equation. In our case, let's avoid this unit for now. This is just a unit. Let's get rid of this one. Okay, in this case we have 2 di by dt plus 10I is equal to 40. In the standard form, you can see in front of this dy by dx we don't have anything. That is standard form. We shouldn't have anything. Here we have 2 is in front, right? So we have to get rid of this 2. If we want to get rid of this 2, we have to divide everything by 2. Divide everything by 2. Then you will get di by dt is equal to 5I, that's plus 5I, that's equal to 20. Now this is in standard form. Now we have to make sure again we have a function of x, we have another function of x. Now it can be a constant also, because if it's a constant alone, you can think it as we have a function. In this case it should be function of t, but we don't have any t. It means t power 0. We can think it as imaginary t power 0, like invisible t power 0 is over there, and think it as this is a function of t, and this is also a function of t. Okay, now this is in standard form, and whenever we bring this first order linear differential equation in standard form, the next thing is we have to find out the integrating factor. To find out the integrating factor, we use this formula: mu is equal to e power integration of p of x. In this case, that's p of t dt. Now p of t is the value that's multiply the y value, y terms. In this case, I is treated as y, so whatever the value that's multiply I, that's going to be the p of t. In this case, that's 5. Okay, so let's plug it in this equation. Mu is equal to e power integration of 5 dt, and if you integrate 5, that's going to be just 5t. So this is going to be e power 5t. Now let's go ahead and continue right here. Okay, let's continue here. So this is going to be what? Di by dt. Okay, after we find out the integrating factor, and we don't have to worry about we should have a constant right here, but we don't have to worry about this one because we are going to multiply both sides by the integrating factor. So when we multiply, the constant is going to cancel anyway, so we don't have to worry about the constant. So let's go ahead and multiply everything by integrating factor, that's e power 5t. Okay, so when we do that, this is going to become d by dt, and we bring this I e power 5t. Now if you take the differences, I just wrote the first. Okay, let me write the whole term first, then I explain what's going to happen. 5I e power 5t, that's equal to 20 e power 5t. Now if you take this term alone, this term alone and differentiate this one with respect to t, you will get the whole thing back. You will get including this 5i e power 5t, because that's the reason of multiplying by integrating factor. After you multiply by the integrating factor for any linear differential equation, you will get if you get the first term, you will get the whole thing back. That's the reason of this, right? Now we can just, since this is equal to the whole thing, we can just directly equate this one to, that's going to be by chain rule. Like when you differentiate, you will get this one by chain rule. Now d by dt I e power 5t is going to be equal to 20 e power 5t. Okay, now the next thing is we have to integrate both sides with respect to t. Integrate both sides with respect to t. Integrate with respect to t. Since we have integration and derivative here, it's going to cancel each other. So this is going to be just I e power 5t. And in the other side, when we integrate this one, 20 is just a constant, and if you integrate e power 5t, you have to divide this one by 5. So 20 divided by 5, that's going to be just 4 e power 5t plus a constant. Now the final thing, the final expression, usually when we have this in terms of y and x, we have to solve in terms of y. Here this I is treated as y, so we have to solve this one in terms of I. Okay, so I is going to be equivalent to, we have to divide this e power 5t both sides, so this is going to become, this e power 5t will be cancelled, so 4 plus c e power negative 5t after you divide both sides by e power 5t. Now this is our final solution, but we are not done yet. This is we can also write this, since this is a function of t, we can write it as I of t as well. And we are not done yet because we have initial condition, so we have to solve for the initial value problem. We have to find out the particular solution. This is general solution of the differential equation. To find out the particular solution, what we have to do is we have to plug the initial condition and see what we get. Now to plug the initial condition, we know that I of 0 is given. I of 0 is equal to 0, so we put 0 right here, and this is when the time is 0. So 4 plus c e power negative 5 times 0. E power 0 is just 1, so c is going to be equivalent to negative 4. Okay, that's the constant value. Now after we find out the constant, we are going to plug it back in this equation. So I of t is going to be 4 minus 4 e power negative 5 t. Okay, so this is the particular solution of this differential equation. And if you want to find out what is the current after 0.1 second, you have to just plug 0.1 instead of this t, and that's gonna give us the current. Okay, if we plug this one, let me try this one. I of 0.1, 4 minus 4 e power negative 5 times 0.1, that's going to be negative 0.5. Okay, Alexa, what is e power negative 0.5?
Sorry, I'm not sure about that.
Okay, Alexa is not answering. Let me calculate that one. Oh, okay, let me calculate this one. I haven't calculated this before. Okay, so here we have e power negative 0.5, so 4 over e power 0.5, 4 divided by e power okay, e power my calculator is messing it up, and maybe I just leave it as it is, you know. Finally it's going to be just, if you plug this like in the calculator, you're going to get the final answer 4 minus 4 e power negative 0.5, and if you calculate this one, that's going to be the current after 0.1 second. And that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.